Hello, Kusampo. Welcome back to the session. We somewhere left at um, working with data model, where we started with working with vector, and we completed extraction of area of interest in vector model. Now let us look at raster. I'll be looking at what raster data looks like in GIS and letting you know basic thing about raster lab. And during unit 2 we have a few exercises to deal with raster, and even in unit 3, 4, 5 we have lots of activities to deal with vector as well as raster. So it's very important that we know what exactly is raster data and how exactly it looks like in GIS lab. So let us look at it in GIS. I've opened my ArcMap again. This time I'm going to go to catalog and check out my raster data lab. So I'm going to look at digital elevated model folder over here. It should be with you in your data list. So just wanted to tell that we have raster data in the form of climate data for Bhutan. We have raster data in the form of dam, and rest we are having in vector format. However, we can also convert rest vector format into raster tool. So for now, let's look at those data which are actually in raster. So if I just open my dam data, meanwhile it opens a DM is an abbreviation for digital elevated model. Its abbreviation stands for digital elevated model, DEM, and DEM is basically data for altitude, and from there we can from DEM we can take out slope, we can take out aspects, we can do hill shades, we can do we can find out contours, and we can also do hill shades of many applications. Okay, hill shade is already said, so we can also do view sheet of many applications that DAM is capable to do. So this is all about DAM. So I'll be looking at just giving you a brief introduction to what is raster data and how do we look at raster data. So let us do this exercise on know the data. I'll be dragging in DAM Bhutan. If you have DAM Bhutan, then that's well and good. If you do not have, then you should be having Raster DAM. So that should serve the purpose. All right. So this is raster file, specifically DAM file. This is raster because this is made up of continuous data, for example, elevation. And raster data, like I said, is made up of pixels or square equal grid cells. So let us just maximize and let's see what it's called as raster. So if we just maximize slightly, if you can notice here or not, but there are square blocks here. If you can notice or not, there are square blocks. Basically, these are made up of squared cells, and each cell, like I said in beginning of my lectures, each cell will depict only one value. So just know about raster that raster is being represented by pixels, and each pixel or each cell will be representing only one value. So raster is basically a file made up of pixels or square sized cells, but it's not necessary that it has to be in square size, but it can be also in rectangle format. But however, most of the time we are dealing with square shaped cells. for raster files. So if you do like this, we can also see that these are made up of square blocks. So that's it on how it looks like. We can meantime do some analysis with raster file. How to read specifically digital elevated model. So it's stretched right now. The values are stretched from 28 to 7522. And if you look at towards the right bottom corner of our arc maps data frame, then we see that the unit is in meters. So that means the unit of the dam is from 28 to 7522. So 28 meters to 7522 meters. So that means darker ones are low altitudes. So that means the black ones which are passing all the way through the valleys, the black ones which are towards the lower foothill of the country are basically black. That means they are basically lower altitude. So that's true because we have got low altitudes like Samchi, Finsling, part of Sarpong, part of Samtujongkar towards lower altitudes. So they are basically darker in color. But if you look at higher or if you look at the grade portion or whiter regions, these are basically high altitudes. So the highest altitude corresponds to 7,522 meters in Bhutan. So that's on the introduction to the raster files. If you go to another raster file, let me introduce to climate raster file. So let's just take one of the files, for example, annual mean precipitation. So I'm bringing annual mean precipitation here. So this one, how to read annual mean precipitation. Instead of annual mean precipitation, this is for whole extent of Bhutan. We are getting even for some part of India, even for some part of China. So how to read? It's in millimeters. So the lowest or the areas with this dark colored regions are receiving the lowest rainfall, mean annual rainfall or precipitation of 236 millimeters. And if you look at some white regions, mostly towards lower foothills and towards the valleys, they are receiving about 4,684 millimeters of rainfall annually. Let's look at another file. Let's look at annual mean temperature. So annual mean temperature, this is the data for annual mean temperature. So reading annual mean temperature is slightly different than reading precipitation and dam. So in annual mean temperature, we have to put a decimal point or just a point after second digit. So in higher sides, we have to put decimal after 4 and before 6. So the way it's to be read is 24.6 degrees Celsius, and the lowest is negative 11.7 degrees Celsius in Bhutan. So if you read the maps, it corresponds to the lowest towards the darker regions, mostly towards the high altitudes of the country, and these are having the lowest values of negative 11.7, and the whiter ones are the warmer areas, having a higher annual mean temperature, having around 24.6. So all the values which are between 24.6 to negative 11.7 are represented by different colors. So we'll be looking at how to categorize these stretched values from lowest to highest in next session. But for now, just know that these values are quite stretched from lowest to highest, and we can also categorize based on the range that we need. For example, in altitudes, we can categorize from 28 meters to, we can categorize till 600, for example, and 600 to 2000, 2000 to 5000. So such kind of categorization can be done even for annual mean precipitation. We can categorize into different categories there. We can basically play with numbers and make it into different classes, and accordingly we can see different colors represented on the maps. Similarly, like that, we can also do with the temperature. We can categorize based on the range of temperature that we need for our analysis. So this is it on this session. Just to introduce you on what is raster and what are different kinds of raster that you may overcome when we are doing with GIS analysis. So three most common raster that you will be overcoming are DAM, annual mean precipitation, and annual mean temperature. From DAM we can take out lots of things. Like I said, we can take out slope aspects, hill shades. We can do hill shades. We can then take out a contour. We can do V shade and all. So reading of all those things are a bit similar to the reading of DAM. On the reading again, we'll try to learn when we are doing analysis related to slopes and aspect lab. But for now, let us just look at the categorization of this data. So in next session, I'll be looking at categorization of this data.